composite functions. How do we evaluate composite functions? Now, let us consider the given question here. So the question says, given that function f is 2x and function g is x minus 3, find number one, f of g. We have two functions here, f and g. So we have to find f of g. So the first question. So we're going to have f of g will be equal to, we need to apply the function here. F of x is 2x. F of x is 2x. So f of g will be 2g. Going by what we have here. Now g, we need to replace g here with its value. Here g is x minus 3. So we need to replace this g with its value. So doing that, we're going to have 2 into x minus 3. We need to put x minus 3 in brackets simply because it is a compound term. So from here, so we're going to have, open the bracket, 2 times x, so we have 2x, 2 times minus 3, so that will give us minus 6. So that is the answer to, that's f of g is a 2x minus 6. So let's take the second one, question number 2. So we have f of g of f. F of g of f. Here we have three functions here being put together. F of g of f. Now, we start by replacing the function on the right here, f, with its value. So we don't touch this first two. So doing that, we're going to have f, g, then f, the last function in f is a 2x. So we replace this f with 2x. So we have 2x in brackets. So from here, we have g of 2x. G of 2x here. So we're going to apply this. Function g is x minus 3. G of x is x minus 3. So therefore, going by that, g of 2x will be 2x minus 3. Remember this f, we leave it like that. We are dealing with g of 2x first. So g of x is x minus 2. X minus 3. G of 2x will be 2x minus 3, going by the definition of function g here. So from here now we have function f left. F of x is 2x. F of x, 2x. So f of what we have in this bracket will be 2, that which we have in the brackets, 2x minus 3. So from here, you can open the brackets, 2 times 2x, so we have 4x, 2 times minus 3, so we have minus 6. So that is the answer to that. So f of g of f, the answer is 4x minus 6. Now let's take the last one, question number 3. So we have f of g of f of 2. So how do we go about this? There are two ways of doing this. Method 1, we have f of g of f here. We also have f of g of f here. From here, f of g of f, we got that to be 4x minus 6. Now we have f of g of f2 now. These two we can substitute here. So that we have 4 times 2, 8. 8 minus 6, that will give us 2. So our final answer there will be 2. If you are to use the answer here directly. However, if you don't want to use the function we get here, the function we have here, if you don't want to use that, you can still do it this way. So we have f of g of f of 2. So we start with the last function here, f of 2. From here, f of x is 2 times x, that's 2x. f of x, 2x. We have x here, we have x here, 2x. So f of 2 will be 2 times 2. The first two functions then, we leave them, we don't touch them. f, g, but f of 2 here, going by what we have, f of x is 2x, so f of 2 will be 2 times 2. And that will give us f of g of 4. So from here now, we have g of 4 as the next function from the right. We still leave this untouched, f. So g of 4, going by the definition of function g here, g of x is x minus 3. So g of 4 will be, in brackets, it will be 4 minus 3. So from here, we have 4 minus 3, so we're going to have f of 1. And finally, f of 1, from here, f of x is 2x. So f of 1 now will give us 2 times 1, and that will be 2. So we're going to have the same answer, whether we use this approach or we use this approach. So this is how we go about evaluating composite functions.